Hello everyone, now let's try out something a bit more difficult. At least it's going to seem difficult to you at first because we have these crazy, terrible shapes right here. And you're like, oh no, it's not a simple shape, and you're right. It's not a simple shape. But luckily we can find out everything we need to know about these guys in the appendix. In this case it's a channel shape, see the C right here. And because of that we know one thing, well its centroid is right at its center. And it is 15 inches tall, which makes its center be 7.5 from the bottom. 7.5 from the bottom. So to its centroid would be 7.5. And their areas, if you look at the tables, they're going to be equal to 11.8 inches in the Appendix C. Okay, 11 inches squared. So without any further ado, let's solve this problem. It's made up of 4 shapes. Rectangle, rectangle, and 2 side shapes. So let's make those. Okay, we got our little table here. So rectangle top, rect bottom, side 1, side 2. And I want to find the centroid in this direction. So it's going to be somewhere around here. And I don't have to worry about the x direction because it's symmetric. So we'll figure out the area, then the y squiggly, then the area times y squiggly, and our sum. And we're going to multiply them all together. So I get all of these like this. Being very careful to make sure I have all my little spots in my table, because the table is magic. Never forget that, the table's magic. And we begin. So the top plate has an area of simply 16 times 1, so that's 16 inches squared. The bottom plate has 14 times a half, so it'd be 7. Side 1s and 2 are 11.8. And if I add those together, what do I get? Let's see, 23.6 plus 23 gives me 46.6. Okay, now the centroid locations. For the top one, it is half an inch plus 15, so 15.5 inches. Plus another half inch, that would be 16 inches. Find this half inch, then this 15 inches, and then another half inch. The bottom, it is half the height, so it would be 1/4 inch. For side 1 and 2, it is this half inch plus 7.5 inches. So it's 8 and 8. Then multiply everything together. So 16 times 16. If I remember my times tables correctly, I'm going to limit saying 176. But I'm pretty sure that's wrong. Actually, I think it's 256. I think I'm just really super off. You know what? Let's try to do it in my head. 16 times 16 is 256. Okay. Thank you, like 3rd grade times tables. Okay, 7 times 1/4 is going to be, I'm not even going to try. 7 divided by 4. 1.75. I could have probably done that. 11.8 times 8 times 8, 94.4. Okay. Then I add them all together. So that would be 256 plus 1.75 plus 94.4 plus 94.4. And I put them all together and I get 446.55. And look at that. We're pretty much done with this problem already. It is so fast with the table method. You just write the stuff down, you add them all together, and you're pretty much good to go. So with that in mind, let's finish it. So my y bar is going to be equal to the sum of my area times y squiggly hat all over the sum of the areas is going to be equal to 446.55 all over 46.6. And so if I do that, what do I get? I get 446.55 divided by 46.6, which comes out to be 9.58. Okay, equals 9.58, and that is right on the money. Now let's check to make sure that this is correct, at least makes sense. This is fairly symmetric. It's not 100% symmetric because you've got a bigger top plate than I do bottom plate, but it's fairly symmetric. So we would guess it would be somewhere near the center. Well, the center of this is going to be half of 15, which is 7.5, plus a ½ inch. So that would be roughly 8 inches up. I mean, if we're going to take the full height, that's 15 plus 1.5. So half of it will be 8.25. So this is just a little bit above that, and that makes sense because I got a bigger top plate, which will be pulling it higher. So all is well. This makes sense. Visually, these should make sense. You should be able to look at it and say, like, okay, I can see why the centroid would be there. If it's completely off the wall, if it's outside the part, something like that, then something's probably gone wrong, okay? If it seems really, really close to one side, something's also probably gone wrong. You should check it. Doesn't mean it's necessarily wrong, just that you should check yourself before you wreck yourself. Okay, so that's enough for this time. Thank you all for listening. I hope this helps you see how you calculate centroids and center of gravities. And if you want to, go over and hop over, you can see some example videos too, where I do more just book problems rather than going through the examples in your book. Thanks for listening. Bye-bye.